All right, so today we're going to start taking a look in Chapter 3 at another type of arguments we're going to use with logic. This is sometimes you'll see this taught in a couple different courses on campus. This is one of them. Those of you who are education majors and might be taking elementary math 1, 2, 3 kind of courses, you'll see this come up again in there. And if you take math for critical thinking, not math for critical thinking, I think it's just called critical thinking, this topic again comes up in that class. So this is a critical thinking, a logic type of section, all right? So we're going to take a look first in what we mean by statements. A statement is a declarative sentence that is either true or false. And I can give you an example. For example, I ate, let's go with eggs. Eggs for breakfast. Okay, so now today that happens to be a false statement, but it's either true or it's false. Okay, you're either one or the other. Can somebody give me an example of something that's not a statement? Finish your homework. What is that, Alex? That's what it's called? Sorry, you didn't know that was going to be a two-part question, did you? It's a command. Yeah, we actually call those commands. So it's neither true nor false. Now, I could change your statement into a sentence, right? But the way that it was stated as it was a command. So it's not a statement. There's another type of sentence that we use that is not a statement. What? A question. Right? So if I ask you a question, like, what is your name? Well, the answer is not true or false. It doesn't make any sense, right? So, yeah, that's not a statement either. All right, so looking at these next two, we're going to decide if they are statements. Yield to oncoming traffic. Is it a statement? No, it's actually what? Did you just say a suggestion, Tyler? It's a command or a declarative sentence or something like this, yeah. This is not a statement. How about the next one? 1 gallon of milk weighs more than 4 pounds. That is a statement. Now, we're not assessing whether it's true or false, but it is one or the other, right? So this is a statement. All right, so a compound statement has two words in the description already, compound and statement. So in order for you to have a compound statement, it has to be a statement. That seems sort of reasonable, right? It can't be a compound statement if it's not even a statement. The other thing is that it has to be compound, which means it has to be formed by using either two or more statements that we already had. So if you join two or more statements together, you have a compound statement. And there are 3 ways of joining statements together. And those are joined with connectives. So there's 3 different types of connectives. So let me give you some examples of those connectives. In fact, you could probably give me some. So let me give me an example of a way you could join 2 statements together. And that's the most common one, I think. It's one I think of too. What else? Or. And there's one more. If then. But is a very similar statement to or. It comes in the same place usually, or sometimes with and, depending on the phrasing. If then is another one. So the if comes before the first statement, and the then actually shows up in between them. So these are the 3 most common. These are the ones we're going to talk about. And we're going to talk about another connective. It's not exactly a connective, but your book puts it in there in an awkward place, and I'll mention that when we get there. Okay. So these are the 3 most common ones. So let's take a look at them one at a time. Let me do one more thing before that. Yeah. Let's look and decide if we've got the statements being compound. All right, so statement or problem number 3. If Tom is a politician, then Jack is a crook, is what your paper says. So I have a typo here. We'll change it so that they match. It was nicer to say he was cool, wasn't it? All right, here's crook. Mostly. All right, so if Tom is a politician, then Jack is a crook. Is this a compound statement? Yes, it's compound because what connective is it using? If, then. And we have 2 individual statements that are making it up, right? They can be either true, they can be false, but they're making this up. So this is a compound statement. How about number 4? Tomorrow is Wednesday. No. What's wrong with this one?
It doesn't have a conjunction.
There is no conjunction, and the reason there's no conjunction is because there's only one statement, right? I just have one statement here. So if I were asked the question, is this a statement? The answer would be yes. Is it a compound statement? The answer is no. So you have to be careful with what the directions are asking. Some of you do a better job of looking at those directions than others. I think you're just trying to get done. So be careful you actually do what the problem asks you to do, okay? Here is the other statement, or the other type of operation, or your book's calling it a connective, but it doesn't actually connect anything. But a negation is another effect that something can have on a statement. So this is the logical opposite of a statement. And let me give you an example that's a real basic one, going back to an example I gave earlier. I gave an example about breakfast. I ate eggs for breakfast, right? What would be the logical opposite, the negation for that? I didn't, or I did not eat them for breakfast, right? So notice what didn't happen. I didn't say, maybe I ate eggs for breakfast. I didn't say, I ate cereal for breakfast. You actually have to take what's there and completely reverse it. And for what we did on that one, you might be looking at it and say, well, that was easy. Why are you making a big point about it? And the reason is because when we get down to the next statement, it matters, and it's not as easy. There are two different types of quantifiers. One type of quantifier is called a universal quantifier, and the words you see used when universal quantifiers are present are the words all, every, none, or never. Something that's very definitive. The same words you know that your mama said you should never use. Never say never, right? You don't always do something, but we say the word always like we really always do things all the time. Those are the kind of words we're talking about. Something that is very strong and it applies to everything. Okay? The other type of quantifiers are existential quantifiers. Existential quantifiers simply say something exists. That's where the word existential is coming from, is an existence. And so when you have existential quantifiers, they apply to some of the people, or one person, or one type of whatever. They're not applying to everything. So you see the words like some, there exists, at least one, those kinds of phrases when they're talking about existential quantifiers. And the reason that this matters is because when we create negations of statements that have these words in them, they're harder to work with. Okay? How do I change something from always? Do I change it to never? You can change it to sometimes as well, so we have to be careful. We have more than one option than simply putting the word not in like we did in the last example, right? So we have to be a little bit careful. So here is the deal. All we have to do to change a negation is if it's got that always strong statement, we turn it into the weaker one. So the word always, the word never, those are universal quantifiers, and we turn them into existential quantifiers. If we have the words some and there exists and at least one, those sort of very lightweight kind of things, like sometimes I unload the dishwasher. Okay? We change them into a stronger statement, either the always or the nevers, those kinds of things. Okay? And before we do these examples, I'm going to give you an actual example of something that happened this semester in one of my classes. I teach an elementary math class. It's elementary math 1, I think it was. And in that class, we started out the first 2 class sessions. It's Tuesday, Thursday class. And no, it's Monday, Wednesday, Friday class. It was the first 3 class sessions. And everyone in the class is female. Now, This happens sometimes in the education field, right? And so this isn't a big surprise, it's no big deal, but I do have a class and there's 19 ladies in the class. And the next day of class we actually had somebody add, and it's a guy, okay? So up until the point when this boy added the class, I could have said, everyone, all of my students are females. And the only thing that it would take to make that statement false is one guy joining the class. I didn't need all the women to drop and all the men to add. All I needed was one person to show up to class that was not a female. Are you with me? So what you're talking about is the very least thing that you could change that would make it the opposite of what was originally meant, would make what the original statement was false. Okay? So we're going to do an example, and there are two different ways that you can do this. When you start out with a existential quantifier like the word sum, you have to change it into a universal quantifier. But there's two ways to do that with universal quantifiers. I could change the word sum into what? All. Or I could change the word sum into none or no. Are you with me? So I'm going to write two different answers for this problem, not because you have to write two different answers, but because what I want you to see is that there's more than one way sometimes to reword this, and both of them are correct, but they don't sound the same. One of them typically will sound very much like the English you use, and one of them will sound a little bit awkward, but they're both technically correct. Okay? All right, so let me do, I don't know, you guys said all first, so let's do the all first. So I'm taking the word sum, and I'm going to change it to all. So I'm going to say all books. I need a statement that makes this statement false. So I have two options. I either say all books are longer than this book, or all books are not longer than this book. Which one makes the statement false? Not longer. Because if some books are longer than this book, and I said all books are longer than this book, that's just a stronger statement than the statement I started with, right? Some books are longer, all books are longer. I didn't change the meaning behind the words. So I would say all books are not longer than this book. And resist the urge to change that phrase not longer into shorter, because that's not the only possibilities. What's the third possibility? What was it? Did you say, Clinton? They could be the same, right? I could have equally long books. So you can't just change it into sort of what we think of as being the opposite, because we do have some middle ground. Not always, but most of the time there is a middle ground. And that would be a case on this one. So this one sounds a little awkward to me, right? All books are not longer. It just sounds awkward to say not longer. It's a little strange. The other one actually sounds a little bit more correct on how we speak. So instead of changing it to some books, we're going to change it to no books. We're not going to say none books because that's not English. It's not correct English. Okay, so no books. No books what? Do we say no books are longer than this book or no books are not longer than this book? What's the opposite of what this says? No books are longer than this book. So in essence, what that means is you found the longest book there is, right? And that is exactly what this statement is not saying from the beginning, that this book is the longest, or at least no books are longer than it is. The same as it. Okay, are you with me? All right. The next question is, it has an equation, sort of. It's not an equation, it's an inequality in it. But we've talked about one way of changing something in Chapter 2 into something that means not something else. In fact, you just had a question on a test where you had to put in the element symbol or the element symbol with a slash through it. What does that slash through it mean? Not. Okay? So, and you know this from algebra and whatnot, right? You got the equal sign and you put the slash through it and it means not equals. So very technically on this next problem, you could put a slash through it and it would mean not. But that's what this description right here at the end is telling you that it doesn't want you to do. So I want to clarify what that's talking about. Do not use the slash symbol. Okay? So while that would technically be true, that's not the point of the problem. So this is not quite so bold on my screen, but this says x is greater than or equal to 5. What is the logical opposite of that? x is less than 5. So what you should notice is that one of them has the equals underneath it and the other one doesn't, right? So, likewise, if I started with this statement right here, the one that I just wrote down, x less than 5, the logical opposite would not just be greater than. It'd be greater than or equal to. Okay, so you got to cover all your bases when you're doing the negations. Okay, and that's what that's doing for you. Okay, let's see. Yeah. All right, the next, this box actually is a box of symbols. And this is where it's calling something connected that's not really connected, but I just am following what your book did, so you don't have to like it. Sometimes we just have to do it, right? Okay. The first connective is actually the connective that means not. Okay. And we talked about that on a couple slides ago, and this is a negation statement. When we introduced that not, and we've created several negation statements now. The symbol that's used for a negation is a tilde, just like on the keyboard. So if you had a statement, for instance, that looked like P, then its negation, the opposite of it, would be written tilde P. Okay? That's negation. Now, we did run into two legitimate connectives a little bit ago, and the first one being and, that you guys mentioned. And the second one was or. And I promise we'll get to the if then, but it's a couple sections down the road, and we'll have some notation for that when we get there, okay? The and symbol is an upside down V, and the or symbol actually is a V. Okay? The type of statement that is an and statement is called a conjunctive. Conjunction. Is that wrong? Yep, conjunction. And the or statement is called a disjunction. So let me show you how the symbols work for this. So if you have statements P, and let's say now we have a statement Q, because I need to be able to join them in some way. So if you have a conjunction, you would do a P, the upside down V, and then Q. That's a conjunction statement. And then if you had a disjunction, you would have a P, and you'd have a V, and then a Q. Sorry, I'm running out of space in the bottom of my screen. So again, this is like what we talked about in the last section. This is the math shorthand. This is the texting language of math. It's existed a lot before your texting. Okay. So this is the shorthand. This is the stuff that keeps you from having to write multiple things or write something a bunch of times or write more words than necessary. And you're going to want this language very quickly because when we create some tables, in another chapter here, another section of this chapter, if you had to write all the language, you'd run out of space on your paper. So these symbols are going to be able to make it so that you don't have to write as much. And that's really the point of it. Okay? And we're going to pause right there for today.